Hello and welcome along to another episode of Bite-Sized Maths. In this class, we will only be seeing some examples, two of them which will be easy, and one example will include trigonometric functions in matrix multiplication. So let's get started. So for today's class, the first example that we will see, the first of the simple ones. Example number 1. Let's say our matrix A is 0, 1, 2, 1, 2, 3, and 2, 3, 4. And matrix B is 1, minus 2, minus 1, 0, 2, and minus 1. So our task is to see and find out if AB exists, if BA exists, and if they exist, what are their values. So let's get started. So first off, we'll compare the orders. A is of order 3 by 3, B is of order 3 by 2. So if we multiply in the order A into B, we see the number of columns matches the number of rows. So AB possible. Now we multiply in the opposite order, 3 by 2 and 3 by 3. Now you see the number of columns 2 does not match the number of rows. So B into A is not possible. So now let's start finding out the value of A into B. So let's call this matrix C equals 0 into 1, 0, plus 1 into minus 1, minus 1, plus 2 into 2, 4. 0 into minus 2, 0, 1 into 0, 0, plus 2 into minus 1, minus 2. 1 into 1, that will be 1, plus 2 into minus 1, minus 2, plus 3 into 2, that will be 6. In a similar fashion, 1 into minus 2, minus 2, 2 into 0 is 0, plus 3 into minus 1 is minus 3. 2 into 1 will be 2, plus 3 into minus 1 will be minus 3, plus 4 into 2 will be 8. 2 into minus 2 is minus 4. 3 into 0 is 0, plus 4 into minus 1 is minus 4. So if we simplify this, minus 1 plus 4 is 3, 0 plus 0 plus minus 2, minus 2, 1 minus 2 plus 6, that is 5, minus 2 minus 3, minus 5, 2 minus 3 plus 8, 7, minus 4 minus 4, that is minus 8. So this is our resultant matrix. In a similar way, let's take another matrix for example. This time our matrix A is 1, minus 2, 3, 2, 3, minus 1, minus 3, 1, 2. And our matrix B is 1, 0, 2, 0, 1, 2, and 1, 2, 0. So we will repeat the same exercise on this one. So again, if they are possible, and what are their values. So in both cases, the matrix order is 3 by 3. So multiplying them in both the orders is possible. So now let's start calculating. So let's call our first matrix as C. It will be 3 by 3, 1 into 1, 1, plus 2 in, minus 2 into 0 will be 0, plus 3 into 1 will be 3, 1 into 0 will be 0, plus minus 2 into 1 will be minus 2, plus 3 into 2 will be 6. Now 2 into 1 is 2, minus 2 into 2 is 4, minus 4, and 3 into 0 will be 0. Now row 2 into 1 will be 1, 2 plus 0 minus 1. I'm just omitting that final step. 2 into 0 will be 0 plus 3 minus 2, and this will be 4 plus 6 plus 0. The final term will be minus 3 plus 0 plus 2. This will be 0 plus 1 plus 4, and this term will be minus 6 plus 2 plus 0. Simplifying it further will give us, this is a plus sign, 4, 4, minus 2, 1, 1, 10, minus 1, 5, minus 4. So this is the, oops. So this is the end result for our first matrix AB. Now let's do the reverse. Let's call this matrix D. So now we will be multiplying B into A. So 1 into 1 will be 1 again, plus 0 into 2 plus 0, plus 2 into 3 minus 3, minus 6, 1 into minus 2, minus 2, plus 3 into 0 is 0, plus 2 into 1 is 2. Element 3, this will be 3 plus 0 plus 4. This will be 0 plus 2 plus minus 6. Let's start that very quickly. This will be 0 plus 3 plus 2, and this will be 0 plus minus 1 plus 4, and the last row will be 1 plus 4 plus 0 minus 2 plus 6 plus 0 and 3 minus 2 plus 0. So this will be minus 5, 0, 7, minus 4, 5, 3, 5, 4, 1. Now again, as we have seen in previous classes, just because A into B exists and B into A exists does not mean that they will be equal. You can see it again over here. So if you see 4, 4, 2, minus 5, 0, 7, 1, 1, 10, minus 4, 5, 3, minus 1, 5, minus 4, 5, 4, 1. So they are not the same matrices. So now let's get to the third example of the day. Given two matrices, cos square theta, cos theta, sin theta, cos theta, sin theta, sin square theta. This is our matrix A into matrix B, which is cos square phi, cos phi, sin phi, cos phi, sin phi, sin squared phi. Prove that multiplying these two matrices will give us a null matrix of order 2 by 2 under the condition given theta minus phi equals pi by 2 radians. So now let's get started. So because we know this condition, this simplifies to theta equals to pi by 2 plus phi. So let's convert our first matrix entirely in terms of phi. So as we all know, cos pi by 2 plus phi is equal to minus sin phi, and in a similar fashion sin pi by 2 plus phi will result in cos phi. So using these two substitutions, our first term becomes sine squared phi minus sine phi cos phi minus sine phi cos phi and cos squared phi. So this is how our first matrix modifies to, and our second matrix remains the same, cos square phi cos phi sin phi cos phi sin phi and sin squared phi. So now let's multiply them together. So sin squared phi cos squared phi plus minus sin squared phi cos squared phi. Whoops. Second term becomes sin cubed phi cos phi plus minus sin cubed phi cos phi. Second term becomes minus sin phi cos cubed phi plus cos cubed phi sin phi, and the last term of the matrix becomes minus sin squared phi cos squared phi plus sin squared phi cos squared phi. So now if you take the sum of all this, this cancels out this cancels out this cancels out this, and this cancels out this, leading us to a net matrix of 0, 0, 0, 0, which is a null matrix of order 2 by 2 as asked. So that will be all for today's class. If you liked it, leave a like and share the video with anyone who finds it useful, and subscribe to the channel if you want to see such videos continue, and till then, sayonara.